So at the first of this unit, we talked about direct variations and how that looked like when you graphed it, right? If I have y equals a constant times x, right? It was a line going through the origin, okay? And it could be going that way, right? It could be positive or negative. So now we have, we're graphing an inverse variation, all right, which is also called a reciprocal function because instead of y equals k times x, it's y equals k divided by x, right? So right here is our parent function, and it's 1 divided by x. And then notice we have our excluded value, and you can see why if you look at the graph. Okay, we can't divide by 0, so x cannot be 0, and then look what happens on our graph. We have this happening here, all right, when x is equal to 0, the graph goes nuts, right? It goes to positive infinity and to negative infinity at the same time. And so remember, that's why we say this vertical line is undefined, right? It has an undefined slope. You don't know if it's positive or negative. It's actually both. Okay, so that is what a reciprocal function looks like, or an inverse variation function looks like that. And it has a name. It's called a hyperbola. So kind of like parabola, but hyperbola. So there's one, here's one. All right, so it says circle the graph that shows 12 divided by x. So it's going to be a hyperbola, so it's definitely not that one, okay? Notice if we look at our graph again, it matches this one when x is negative, and actually this is y equals 1 over x. I can make that a 12, and we'll graph it. And you see it kind of, that's a stretch, right? We're talking about transformation, so that would be a stretch. Notice it's farther away from the origin, all right? But it's easier to see what's happening here. You can see when x is negative, y is also negative, okay? And then when x is positive, it's a positive function. Right? Because if x is positive, this whole thing is positive. And if if I have 12 over a negative, the whole thing would be negative. Okay. And then at 0, right, if that was 0 in the denominator, that's where you get your problem. Okay? And this is actually called our vertical asymptote. And that is a very important thing we're going to talk about in this unit. And then we also have this happening here. Now when we talk about the end behavior, right, our end behavior, we're talking about horizontal asymptote. Because both ends are approaching the same number. They're both approaching 0. All right, so this is our new vocabulary for this inverse function, or this reciprocal function. You have intercepts, which we already know, all right, where the graph crosses the x or y. This is our new word, asymptotes, all right, and then asymptotes are an invisible line that the graph is approaching, all right, but never touches. That's an asymptote. And so if you look over here, we have a vertical asymptote, which is this vertical line right here. All right, and if it's vertical, right, a vertical line is always x equals something. So in this case, x equals 0. All right, and then you have a horizontal asymptote right here. All right, that's your horizontal asymptote. And that is always going to be y equals something because it crosses the y-axis. Okay, and then as always, we have a domain and range for x and y. And then when you're talking about end behavior, remember end behavior is as x approaches positive infinity, what is happening to the function. And as x is approaching negative infinity, what is happening to the function. All right. And notice right here is our end behavior. Right, as we go to positive, well, negative infinity and positive infinity for x. Right, notice that's approaching the same number as our horizontal asymptote. Okay, very good. So, looking at these, what we're going to do is use our graphing calculator, all right? And we're going to look at these functions when we change the a, and we kind of just talked about that for a second. So go ahead and put that into your calculator. Okay, so now a is 3, right? So I have 3 over x, so I'll look at that graph. Okay, so it's the same as the other one, except a little bit closer to the origin. Okay, so I still have my vertical asymptote is x equals 0, and my horizontal asymptote is still y equals 0. And then I can just fill in here, right? When x is negative, y is negative, and when x is positive, y is positive. Okay, so that looks like that. All right. And I could put a major point here. I could put a key point would be y equals, it's 1 over x, so y equals, if a, or excuse me, 3, right? We made that 3 over x. All right, so when x is, y equals 3 over x, so when x is 3, right, y is 1. So I could put that point in there, 1, 2, 3, and then y would be 1 if I wanted to have a better graph. And likewise, when x was 1, it would be 3 over 1, so it would be 3. When x is 1, that would be 3. All right, and that's not too difficult, so I can do that if I wanted a better graph. You just put in some easy points. Okay, and then for if x is negative 3, I'll do that. All right, notice if I make x be negative 3, it's just going to be negative 1. So negative 3, negative 1, and if x is negative 1, it would be negative 3. So negative 1, negative 3. So it is actually reflected across the, oops, yeah. It's actually a reflection across this line, right? Y equals x. Oh, negative x. Okay. All right, so now you can do the same thing, put in negative 5 and see what happens. So what do you think is going to happen if we make that negative? Oh, good. Okay. All right, so now I'm going to put in, make a be negative 5. All right, so when a is negative 5, if I look at the graph, you can see it's reflected. Okay, just like all our other transformations, all our other functions, that negative in front is going to make it be a reflection across the x-axis. All right, so but notice we still have the same x and y, same vertical and horizontal asymptotes. All right, so the horizontal asymptote is still y equals 0. My vertical is x equals 0. But now, when x is negative, y is positive. Okay, so it is, and when x is positive, y is negative. Okay, so it's reflected. And then if I have a decimal, what's going to happen? Okay, so now A is less than 1, right? It's positive, but it's less than 1. So if you remember from before, that would be a compression. So notice it's really squished, really close to the origin. But same horizontal asymptote, same vertical asymptote, but it's a compression. All right, if you have a fraction for A. All right, and so it was very close. Okay. And here it's very compressed. Okay, where these are kind of stretched out. All right, so this would also be a stretch. Right, the negative makes it a reflection, and the 5 makes it a stretch. Okay. So if there's just 3, that would also be, that's just a stretch. Okay. Those are the transformations for A. And then now, did it change the domain and range? No, it didn't. All right, so for example, if we look back up here, the domain, it's going to be, all right, that's my x value, so it's going to be all real numbers except 0, right? 0 is the excluded value for x. And then my range is going to be all real numbers except 0. Okay, and if I write that as interval notation, I would say, okay, that's negative infinity to 0, and then we pick up at 0 and go to positive infinity. Okay, but the 0 is excluded. So, and that would be the same for both of them. All right, excellent. Now you just put these into your calculator, and so now we've got a number added outside or subtracted outside. Okay, so what do you think is going to happen there? Okay, so we've got a number added outside, so what is going to happen? So look, it took kind of that like X, right, that kind of bullseye where the vertical and horizontal asymptotes are, and it just shifted that up 2, okay, because I've got this still is my vertical asymptote is still at 0, right, that's still a problem when X is 0, but now my horizontal asymptote is at 2. All right, so that's all I have to do if I'm going to graph it. I would say, okay, my vertical asymptote, right, vertical asymptote is still x equals 0, right, that's when it's undefined. And then, but now it went up 2, so on the y-axis, so I'm going to go up 2, that's my horizontal asymptote, it's going to be y equals 2. Okay. And then it's still going to be the same if x is negative, y is negative, and if x is positive, y is positive. Okay. And then so you can guess what's going to happen here. If we have a minus 2, right, if we subtract 2, all right, that's just going to shift it down probably. So let's check it out. So I can go ahead and graph that. There's my vertical asymptote. My horizontal asymptote moved down. Okay, and then it's still going to be negative, negative, and positive, positive. Okay. Now looking at this one, all right, so if I'm writing out, and then now this one I have this negative in front, and then I also have the plus 2, so that looks like 2 transformations happening there. Okay, so we've got the negative in front and a plus 2. So let's see what's going to happen there. So that moved up, right? My horizontal asymptote moved up 2, and it's reflected. Okay, just like we would expect. So my horizontal asymptote is up 2. the vertical asymptote stayed at 0. All right, but now it's reflected. All right, so my negatives are positive y's, and my positives are negative y values. So it's reflected across the x-axis. And remember, those are the transformations. So when you're writing out transformations, you would say, okay, this was a shift up, all right, up to, all right, and that was it, okay? Or you could also say that's a translation, all right, up to. And then now this one was just a shift down to, okay? And if we wanted to, we could say that's a vertical shift, right? If you're going up and down, that's a vertical shift. So now here we could say, okay, I've got a vertical shift up to, and then I also have a reflection over the x-axis. So we've talked about the horizontal asymptote, all right? So the horizontal asymptote makes a vertical shift on the y-axis, all right? It's horizontal. So you're going up and down the y-axis, all right? Now if we're talking, and these are called translations, right? Because we're just moving up and down. You're just going horizontal or vertical. You're not stretching or anything. And then so the domain, you need to be able to name the domain and range for each of these as well, okay? Because that's what gets shifted. If you go up and down, you actually change the range. You're not going to change the domain, just the range. So go ahead and graph these and write down what the new domain is. Okay, so I've got a hyperbola because it's 1 over x, but now the plus 3 is in my denominator, right? The plus 3 is in the denominator, so it's kind of there with the x, all right? So how is this going to move? How is this shift going to be? Oh, it moved to the left, just like all our other, just like it did with quadratics and absolute value. Okay, if it's with the x, it's going to move left and right. And it's going to be the opposite. This was a plus 3, and notice this moved to the left 3. Okay, so my vertical, and it was a vertical asymptote that moved, all right? And that is going to be x equals -3, okay? Because the vertical asymptote crosses the x-axis, all right? And then, but the horizontal asymptote stayed the same, right? It was still 0. It did not go up or down. So here's my horizontal asymptote, and then you can kind of just fill in the hyperbola. So negative goes negative, positive, positive. Okay, go ahead and do the next one, and you can check with me to see if you did it right. Oh, actually, I forgot. We're going to do the domain and range, right? So what would be the domain for this one? Well, it's all real numbers, right, except -3, right? That's my excluded value, okay? Or I could say the possible x values for this function are -infinity to -3, and then picking up again at -3 and going to positive infinity. Okay, that's the domain. The range is all reals except 0, right? Because that was where the horizontal asymptote. So the range has to do with the horizontal asymptote, and the domain has to do with vertical asymptote. Alright, so I'll write this as -infinity to 0, and then picking up at 0 and going to positive infinity. Alright, So that just, so if you change your vertical asymptotes, then you change the domain. If you change your horizontal asymptotes, you change the range. All right, so go ahead and do the rest of the page. Okay, now we're picking up on this one where you have all three of the things going on at the same time. All right, so transformations, we have A right on top, so that's going to be a stretch by a factor of 4. All right, and then you have the -3, which is going to shift. It's going to be a vertical shift down 3. Change colors here so we can tell the difference. And then we're going to have this +7, right? It's going to be a horizontal shift, and it would be left 7, right? It's the opposite. So those are my 3 transformations. All right, got 3 things going on there. A stretch, and horizontal and vertical. So the asymptotes, you're going to have the horizontal asymptote. It's going to be y equals something. All right, so that moved, right, it went down 3, so I'm going to go down 3 for my horizontal asymptote. And then my vertical asymptote, x equals -7, right, it moved to the left 7. So there is my vertical asymptote. Fill those in first. And then we can graph, look at the graph. We know it's going to be in here, negative to negative, positive to positive, okay? And so the shifting here changed the domain. So my domain is going to be my x value. So the domain goes from -infinity, and it goes nuts at -7, right, when we have this vertical asymptote. So that is out, because that would make my, if I have a -7, right, that makes my denominator 0. So, and then I pick up again at -7 and go to positive infinity. And then for the range, all right, I'm going to start at -infinity, and then it goes nuts at -3, and then picks up again at -3 and goes to positive infinity. Okay. Then end behavior is, remember, that is as x goes to positive infinity, right? So as x approaches positive infinity, what is happening to the function? So that end behavior is over here, right, at positive infinity. Well, it's approaching this number here, which is -3. It's approaching the horizontal asymptote. And if I look as x approaches -infinity, the function f of x is, that's over here, -infinity, it's also approaching -3. It's going to the same thing on both sides. Okay, these are both approaching the horizontal asymptote. Alright, so go ahead and practice these. Use your calculator to check your answers, all right? And I would do that here. I would type that in my calculator just to make sure that's what it looked like. Okay, good job.